Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Sla YouTube channel. Yes, so today again we are seeing another interesting interview question. So we're going to tackle one of the most and very commonly asked critical performance testing concept, which separates again from the amateur artist from the professionals. So where we're going to simulate the parallel asynchronous request in JMeter. So the scenario or the interview question could be like a user page loads the main HTML, but then immediately he fires three parallel Ajax API calls like get cart, get user, and get notifications simultaneously. So if you put them sequentially in JMeter, the response time metrics will be wrong because they'll be too slow. So how do you simulate this parallel behavior, right? So usually we do this concurrent behavior, right? But here the question goes like this: how do you simulate this parallel behavior? So now this is an excellent question because it tests whether you truly understand how JMeter's thread model works versus how the modern web applications actually behave. So think about it. When you load pages like Amazon, Facebook, or any other modern web applications, the page does not wait for one API call to complete, right, before firing the next one. So everything happens at once, and your cart loads, your user profile loads, your notifications load, and everything happens in parallel, and that's how Ajax works. But here's the problem: JMeter by default doesn't work that way, and if you don't know how to fix this, your entire performance test will be based on incorrect metrics. So let's dive in and understand why. So moving on to the next slide. So let me show you the problem visually, because this is where the most testers go wrong. So on the left side, you see the wrong approach. I wouldn't say wrong, but not the right approach. So this is what happens when you use the JMeter's default behavior. And look at the flow. First, you get into get cart, where it executes and takes, let's say, 300 milliseconds. Then JMeter waits for it to get complete, and only after get cart is done, it fires get user, which takes another 300 milliseconds, and then it waits again, and finally it fires the get notification, which takes another 300 milliseconds. So what's the total time? 900 milliseconds, and 900 milliseconds for just three requests. And now look at the right side. This is what actually happens in a real browser. So the moment the HTML page loads, the browsers fires all the three requests simultaneously. Get cart, get user, and get notifications all start at the same time, and they all execute in parallel. So what's the total time now? It's 300 milliseconds, because they are running at the same time, not one after the another, right? So now do you see the problem? So if you use JMeter's default sequential execution, you are measuring 900 milliseconds, but the real user experience is just 300 milliseconds, and your metrics are 3 times slower than reality, right? And that's what we call a blocking or sequential thread model. So each request in JMeter by default, they blocks the next request until it completes. And this is fundamentally different from how modern browsers handle any asynchronous Ajax calls. So the other issue is JMeter's default thread model does not match the real user behavior. And if your test doesn't match reality, your performance metrics are meaningless, obviously, right? So moving on to the solution. So I have few solutions. So option A is you're going to use the parallel controller. So let's talk about the solutions. So the first and the most recommended solution is using parallel controller. And for that, this is either a native JMeter plugin, or you can even add that add-on depending on your JMeter version, but it's standard in most advanced performance testing setups. So here is how it works. So you add a parallel controller to your test plan, and then you place all the three of your HTTP requests, get cart, get user, and get notifications inside this controller. The parallel controller then executes all these child samplers in parallel thread simultaneously. So instead of JMeter saying, okay, do request 1 and wait for it to finish, do request 2, wait for it to finish, do request 3, the parallel controller says do all the three requests right now at the same time. So the result, your total response time becomes just 300 milliseconds instead of 900 milliseconds, which accurately reflects what a real user experiences. And now let's talk about the advantages. The first thing is it's simple to configure. You literally just drag and drop your requests into the controller. Secondly, it keeps your test plan clean and organized. Thirdly, it gives your accurate response times that match browser behavior. And fourth, it's the most straightforward way to simulate real world asynchronous behavior. The main limitation here, I would say, is you need to install a plugin. In most cases, this is very trivial because you just use JMeter's plugin manager. But if you're working in a highly restricted corporate environment where the plugin installation is not allowed, you might need to use one of the alternative approaches. But let me tell you this, for 95% of cases, parallel controller is your go-to solution. Simply, it's very effective and accurate. And moving on to the next slide, the other solution, I would say the alternate solution. So now let's discuss the alternatives, because in an interview showing that you know multiple approaches will demonstrate how deep are you in, how deeper expertise do you have in JMeter. So the option B, I would tell you, is separate thread groups with inter-thread communication. So this is the manual hardcore approach. You create separate thread groups for each request, one thread group for get another, for get cart, another for get user, and another for get notifications. Then you use the inter-thread communication plugin to synchronize them so they all start at the exact same time. But the reality is this approach is overly complex. Yes, I can understand that. So you are creating multiple thread groups where you have to manage synchronization logic, dealing with potential timing issues, and making your test plan significantly more complicated. It works, I know, but it's like using a sledgehammer to crack a nut. Yes, it's too much of a overly complex approach, and it's rare to see this in practice unless you have a very specific edge cases. And then the option C, the BZM parallel controller from BlazeMeter. So now this is important to know because this is essentially an enhanced version of the parallel controller, which is developed and maintained by BlazeMeter. It's become the industry standard for parallel execution in JMeter. So why I say this approach is better is, firstly, it's widely adopted across the industry. And secondly, it's actively maintained with regular updates since it's from BlazeMeter. Thirdly, it has extensive documentation and community support. And in fact, I have created a video on parallel controller. And fourth, it offers additional features like better error handling and more configuration options. So if you are working in a professional performance testing environment, chances are high that you will encounter the BZM parallel controller. So in an interview mentioning this shows that you are familiar with industry standards, tools, and practices. And now the bonus point is that will really impress your interviewer has mentioned that the standard synchronizing timer does not solve this problem, because many junior testers think, oh, I'll just use a synchronizing timer to make the request run together, but that's incorrect. The synchronizing timer synchronizes threads. It makes multiple thread wait for each other proceeding, but it doesn't make requests within a single thread to run in parallel. So understanding this distinction will show that you truly understood the JMeter's threading model at a deep level. And finally, the very last slide, the key takeaway, and again the best practices, the interview strategies. So let me give you the key takeaway and an interview answer template you can use. So the core principle here is JMeter's default execution is sequential. So the real browsers execute AJAX calls in parallel, and you must use parallel controllers to match the reality. Without this, your performance metrics are fundamentally flawed. So you're not testing what users actually experience. So here is your interview answer template. Follow this structure and you will nail this question every time. So step one, explain the problem clearly. Say JMeter executes requests sequentially by default, which means each request wait for the previous one to complete, and then state the impact. Say that this creates artificially slow response times that don't reflect the user behavior, making our performance metrics inaccurate. And finally, provide the solution. Tell them the solution is to use parallel controller or the industry standard BZM parallel controller plugin from BlazeMeter. This executes all child requests simultaneously, matching the browser behavior. Show the expertise with a bonus point by telling them that it's important to note that the standard synchronizing timer won't work for this scenario because it synchronizes threads, not individual requests within a thread. If you follow the structure, you are demonstrating not just knowledge but understanding of why things work the way they do. And that's what it today. If you find this helpful, and I know you will definitely find this helpful, please like, subscribe, and leave a comment with your questions. In the next video, we will tackle even more advanced JMeter interview questions. Happy testing, and I'll see you next time. Until that, it's bye bye from Asynchronous and your favorite Little Claw YouTube channel. Take care and bye bye.